This is the second part of the video iterators and generators. In this video, we will cover generators, and I suggest you to watch the first part of this video if you want to learn about iterators. And if you're new to the functions in JavaScript, I suggest you to watch the playlist. Both the links are mentioned in the description below. In this video, we will cover the concept of generator, how it pauses the execution of a function, what is the purpose of a keyword like function star, learn to declare a generator function and how to do this in an object and in a class. We'll learn the concept of generator object, yield and yield star statements, and conclude by implementing a generator object to get a good grasp of the concept. Let's talk about the concept of generators. A generator is a feature of JavaScript that allows to pause and resume the execution of a function. The generator simplifies the implementation of an iterator, and this improves the code readability and reduces the likelihood of errors. Let's see an example and understand how a generator works. In this code snippet, I write a function myGenerator. Note that I have used an asterisk or a star right after the function keyword. This indicates JavaScript that I'm writing a generator function and not a normal function. So when I execute this function myGenerator, it returns a generator object. At this time, the function execution has not started. This generator object is a special type of iterator object. Now JavaScript implements this iterator object internally, the same way we have learned in the previous video, where a user-defined object implements the symbol.iterator method, which returns an iterator object, and this iterator object implements the next method. So when I call the next method, the generator function starts execution and executes until the yield statement. At this point, it pauses the execution and gives back or yield a value to a caller. So JavaScript maintains the generator function's present state. Subsequent function call resumes the execution and pause if they find another yield statement or completes the execution. The output of these function calls is the same as what we return in an iterator implementation. Two properties, value and done. When there is no data to return, the value is set to undefined and done is set to true. With the yield statement, JavaScript maintains the state of the generator function and uses it for the subsequent execution. In case a generator function has a return statement, JavaScript, when it executes the return statement, it no longer maintains the state of the function. Now we will see the implementation of a generator function, and there are different ways we can implement it. We can implement this as a generator function, as a function expression, as an attribute of an object, or as a method of a class. We will see all these implementations, and finally we will again implement the book collection class using the generator function to iterate through the list of the books. In the first code snippet, I write a generator function named myCounter. Notice the asterisk right after the function keyword. Now this generator function takes one argument, the max value to which this counter counts. In the generator function, the yield statement gives a user the value of I, and as you notice the console.log statements, the output is same as what an iterator is supposed to return. And once the limit of max value is reached, all the subsequent calls to the next method will return an undefined. In the second code snippet, I am implementing the same myCounter generator function as an expression. So the change here is the function name will now become a variable, and I will store the reference of this expression. And while writing the expression, I will still mention the asterisk right after the function keyword, and there is no change in the implementation. In the third code snippet, I implement myCounter generator function as an attribute of an object. And for this, I create one object, counter. The first attribute is the max value, which sets the limit of this counter. Now the generator function definition starts with an asterisk followed by the function name. In this example, I have given it the name generator, but you can give any name to this function. The implementation remains the same. Now in order to use this counter, I start by initializing the max value. Then I execute the function generator, which returns a generator object. Now I can use this generator object to generate the numbers. Now we will see the fourth implementation of the generator function as a class method. This allows to create multiple counter objects. As a class, the attribute max value is initialized in the constructor function. And just like in an object, I will write a generator function in the class that starts with an asterisk. The implementation here does not change. Now for usage, I start by creating an object of the counter class. Then I call the generator function to get a generator object. And using this generator object, I can now generate the numbers. As we have seen these different ways of implementing a generator function, now I will implement a generator function on the class book collection. Now this class maintains a linked list of books, and we will use this generator function to iterate through this list. The method addNewBook adds a new node to the list, and the class book represents a node that maintains a book name, author, and a reference to the next node. Now for a class to be an iterable, I have to implement the symbol.iterator method, and this method will be implemented as a generator. This means I will put an asterisk before the symbol iterator, which makes the symbol.iterator method a generator function. While implementing the symbol.iterator method, I write a while loop that iterates through the linked list of the books with a yield statement for each book. Note that like an iterator implementation, I have not defined the next method for the class book collection. Now to test the code, I start with creating an object of the book collection class and add a few books to this collection, and then finally I execute the for loop to iterate through the list of the books. Now in case I wish to iterate through the linked list of these books without using a for loop, then I have to execute the method symbol.iterator to get hold of a generator object, and then call the next method on this generator object to iterate the list. This implementation of symbol.iterator method is same as when we implement this method as an iterable iterator, where it returns its own reference and implemented the next method. In this case, it is implemented as a generator function. Now I will share another implementation of the method symbol.iterator, where it returns a generator object explicitly. I start by defining a new class booksIterator with one attribute current book. At initialization, it points to the first node of the book collection linked list. Then I implement a generator function listBooks. Now the implementation of this function is same as that of symbol.iterator method of the last implementation. Note in this implementation, the method symbol.iterator is not implemented as a generator function. This method, when executed, creates an object of the class booksIterator while passing reference of the books linked list. Then this function calls the generator function listBooks to return the generator object. And now we are ready to iterate through the linked list of the books. To test the code, again I start by creating an object of book collection class. Then I add a few books to this collection and execute a for loop to iterate through the list of the books. Now we come to the last topic of this video, which is yield star. We use yield star expression within a generator function to delegate the iteration process to another iterable or a generator function. This allows the yield of a value from another iterable or generator function. We can use this approach to combine the output of multiple generators or iterables. In this code snippet, I write a generator function that uses a yield star on an array followed by a yield statement. So when I execute this code, it yields the array elements and its own yield statement in the end. In the second code snippet, I modify the generator function myCounter to use another generator function myCounter2 with the yield star statement instead of an array. So when I execute the function, the delegation goes to the other function and yields its values followed by its own yield statement. With this, I wrap up the video. Let's summarize what we have learned in this video. Thank you for watching this video. If this video has helped you, please like it. If you think this can help any of your friends, do share it. And finally, do subscribe so that you don't miss any other videos in future. Thank you very much. Keep learning.